Hey everyone, this is Professor Chan from Math 1230 speaking. I'm going to go over this concept called interest. We're going to be doing a lot of financial math. That's going to help you with your project as well as, just other things, dealing with finances. There's going to be several formulas over week 6 and week 7. So let's get started. So we have something called interest, okay? And what is exactly interest? Interest is essentially the amount that is added to your original amount, okay? We have two types of interest. We have one called simple interest, and we have also what's called compound interest. So simple interest is I is equal to P times R times T, right? So I represents interest, P is principal, R is rate, and T is equal to time. We'll talk about this in terms of years. Okay, let me zoom in a little bit. My apologies. Okay, and the total cost is equal to your principal plus whatever your interest is. So what is principal? Principal is the amount of money you start off with. Okay, so the idea is like you put money in a bank, okay, and then you want to see how much money accumulates. The money accumulates is your interest, and then if you add it together, that's your total money or your total cost. So let's take a look at example here. So it says you made a deposit of $1,000 in a bank which pays 5% each year. Find the interest and total cost after 5 years. Okay, so to find this one, to find interest, it's I is equal to P times R times T. My P is 1,000. My R is 5% or 0.05, and my T is 5 years. So I'm doing 1,000 times 0.05 times 5. So I'll throw it in my calculator. And that equals to 250. So my interest is $250. That's how much money I've accumulated or I've added on. But my total cost, right, is not 250. It's the interest plus the amount that I have originally. Okay, so that's going to be it. Okay, so let's do one more example here. So it says the following. It says you deposit $1,200 in an account with an annual interest of 10%. Find the interest as well as the total cost for 6 months. Now we'd be a little bit careful here, right? Remember, we want to talk about in terms of years. So T is not 6, it's 0.5, right? Because 6 months is half a year. My R is 0.10, and my P is 1,200. So I is equal to P times R times T. Okay. And this is going to be 1,200 times 0.10 times 0.5. So if you enter this in your calculator, you should get 60 for your interest. And then your total cost is going to be 1,200 plus 60. That will give you 1,260 here. Okay. Okay. So, I'm going to give you another example. I'm going to talk about compound interest formulas. There's technically two, but I want to kind of give you the more comprehensive version. So, but before we start, let's talk about what's the difference between simple and compound. Okay. So simple interest is you're always doing a flat. Okay. So the idea is simple. If I do simple interest, right, and my rate is 15%, right, I would do the following, right? I would do the following here, right? Simple is I is equal to P times R times T, right? So in our case, it's 100 times 0.15 times 2. This is 100 times 0.15 times 3, right? So I throw this in my calculator, and I get 30. And if I add to my original, which is 100, I have 130. This is 145. This is 160. And notice, as you if you find out, it is going up by the same amount, right? It's going up by $15, right? So it's actually going very linearly. Now, compound is going to be a little bit different because we're actually multiplying 15% to our prior amount. So how compound works is, right, so I did 100 times 15, if it's a 15% increase, I'm multiplying by 1.15, right? Remember, 15% increase, you do 0.15 plus 1, and then I get 115. I'm going to multiply that by 1.15. I would multiply the next part by 15%, start by 1.15. And if you notice here, right, here's a situation at hand. Notice it's actually increasing a lot faster because you're not adding by the same amount, you're actually multiplying by the same percentage. So you can clearly see, right, that it is getting significantly larger. Okay, it's already at year 4, it's going a lot faster. And so what happens is, if you look at this graph, compound interest is exponential, simple is linear. Right, so yeah, so compound interest goes exponential, has exponential growth. Simple interest is linear growth. Compound interest will grow faster than simple interest. Okay. So this is your example right here. I'm going to show you how to do a compound interest formula. Okay. Now in your homework, I'm going to kind of show this to you, or no, assignment in class. It is slightly different. Okay. We use APR and R interchangeably. Okay, so you may see this. Let me rewrite this again. So you can see P times 1 plus R over N to the NT. T and Y is essentially the same thing. Okay, so if you see this, they're very similar. So let's talk about what they represent. A is your new amount. P is your principal. APR is your rate. N is your number of compounds. And Y is the number of years. Okay, sometimes they use T. Okay, and sometimes with APR they just use R. Okay. So let's talk about this here for the following, okay? When you have N, okay, so what does number of compounds mean? That's just the amount of time periods in a year, okay? So if we say we're compounding monthly, we would say N is 12, right? Because there's 12 months in a year. If we say compound weekly, we would say N is 52 because there's 52 weeks in a year. Okay. So let's get started with a problem here. Okay. So it says 15,000 is invested for 15 years with an APR of 4.2% and monthly compounding. So I'm going to do the following here. Let me give myself some space. So I'm using the formula A is equal to P times 1 plus R or APR over N raised to the NT. Okay, so let's take a look at here. My P is 15,000 because that's how much I'm starting off with. My R is 0.042. My monthly compounding, so N is 12. And then I have 15 years, so my T is 15. Okay. Now, when you do this, just be really careful. Do order of operations. Please show your work as much as possible. Okay. So what I'm going to do is I'm going to do 0.042 divided by 12. So I want to do this part here first. So I have 1 plus 0.0035. Okay. I want to do parentheses for both. So 1 plus 0.0035 is 1.0035. I'll do 12 times 15. That's going to be 180. This. Okay. Now, order of operations, what you're going to do is you're going to do your exponent first. You're going to do 1.0035 raised to the 180. I have 1.875546467. And then I'll multiply by 15,000. And I have 28,133. And this is my final answer for here. Okay, let's do one more example. So it says 2,000 is invested for 5 years with an APR of 3% and daily compounding. Okay, so same thing. I'm going to do A is equal to P times 1 plus R over N raised to the NT. P is 2,000. R is 0.03. And since it's daily, it's going to be 365 because there's 365 days in a year. My N is 365, and my T is 5 here. So look at this. Okay, so slow down. Just plug everything in, and then slowly write it out. So first thing I want to do is I want to do the 0.03. Okay, now this is something we want to, so actually this is good that we're looking at this, right? So you have a very tiny number. Now remember, what does this mean? This is 0.000821917.8, right? The negative 5, sorry, 0.0000, right? Because I'm moving the decimal place 5 places over. Now one thing you can do is you can add the 1, right? If I add 1 to it, it looks like this here, okay? So this is 1.000082192. And then I'll raise it to 1825. So let's write this down. I have 1.161827546. And I'll multiply by 2,000. Okay, 23.65. Okay. So one thing I do want to also point out is sometimes I'll ask you what is your percent of interest, or how much is spent on interest, how much is spent on principal. So the idea is you know that $2,000 is for your principal. How do I find my interest? My interest is my new amount, right? So I'll notice I have a total of 23.65. I'm subtracting 2,000. Oh, sorry, it should be 0.66. Let me round up. So I get my interest is $323.66. Okay, so that's how you know, right? Because that's the amount that's extra. Okay, and notice I start off with 2,000, so that's my principal. Okay. Okay, so let's see. Let's talk about the other type of formula that we can do here. So this is in your homework, which is the Who Wants to Be a Millionaire. So I already kind of did compound interest, so you can kind of figure it out yourself. Okay. So let's take a look at this here. This is what's called future value formula. Okay. This looks a lot, okay, but let's explain what this formula means. This formula is essentially like if you are wanting to save for something, and let's say, for example, like you're putting like $200 in a bank every year, right? And then the bank has interest, and the A represents what it represents is, let's say after 20 years, how much money would you have in a bank in total if you keep adding $200 into your bank account? Okay. So PMT is what's called monthly payments. Okay. So that's the amount that you're putting in per month. Okay. So let me show you an example. Yeah, so how much shall we earn in 30 years? Let me copy and paste this here. Sorry, I know it's a 4-part problem. So it says, assume we start saving for retirement. We're going to place $200 per month in a retirement account, earning 6.58% APR. Okay. So it says, how much will we earn in 30 years? So we're going to use this formula. Okay, so let's just kind of plug everything in. So let's see, I have R is equal to 0.0658. I have Y is equal to 30, because that's 30 years. My PMT is going to be 200, right, because I'm plugging in $200 per month. And my, let's see, PMT, RN, oh, and it's a monthly compound, because we're doing monthly payments. So in this case, my N will be 12. Okay. So when I do this, I have to be really careful. You just want to show as much work as possible, right? So I have the A is equal to PMT over all this stuff. Okay, so I'm going to just plug everything in. This is 200 times 1 plus 0.0658 divided by 12. raised to the 12 times 30 minus 1 over 0.0658 divided by 12. Okay. Give myself some space. So I'm going to put this part in my calculator. So I have 0.0658 divided by 12. And then I'll add 1. So this inside here. So this is going to look like the following here. Okay, I'm now going to do 12 times 30. That's 360. I'll also do the 0.0658 divided by 12, the bottom part here. Okay, so it's going to look like this. You want to actually, when you're doing your work, you want to go out as far as possible, because if you round as you're going along, you're actually going to get a slightly different answer. So notice I'm like writing, I know this is kind of annoying, but notice I'm actually writing everything out, right? I'm not stopping after the 4th place. I'm going all the way, like I'm going like 10 places over. Okay. Now when you get to here, okay, order of operations, remember we're going to do exponents, right? I'm going to raise this to the 360, I'll subtract, and then I'll divide, and I'll multiply by 200. Okay, so if I look at this here, so this part here, the 1.054833, I'm raising it to 360. Okay. So I'm going to do this raise to 360. I get 7.16. So I have 200 subtract a 1. Then I'll divide by, I'll do the 6.16 divided by the 0.0543. and I get $224,706.37. Okay. I know this is a lot of work. You just need to slow down. Okay. Make sure you follow your order of operations. Okay. So let's take a look here. So this is what we have here. Now you can double check in your Excel. We're going to be using this quite a bit in the next couple of weeks. So let me show this to you guys right here. So there's a formula in Excel. It's called future value. Okay, so let's talk about this here. So if you kind of watch my screen when I press equal, if I type FV, okay, and I do parentheses, okay, this is saying calculating the future value of a situation. So our case is a future value, right? Right, we're like, what's a future value if you keep putting $200 bills into the bank every month, right, for 30 years? Okay, and if you notice, there's kind of four things. Don't worry about what's called the type, which will so there's four things. There's rate, MPR, PMT, PV, and type. Okay, so rate according to your Excel is going to be R divided by N. So in this case, my R was 0.0658, and I'm dividing by 12, right? Because it's my N. So my rate is 0.0658 divided by 12. Okay, don't get confused with your formula for rate. It's just this is just the way that Excel wants it. The next, and this is what I'll do comma, and I go to the next one. The next one is MPER. So MPER is your number of compounds times the number of years. So I have a monthly compound, so that's 12, multiplied by the number of years, which was 30. Okay. And then the next one is my present value. Sorry, my payment, which was 200. Okay. One thing I want to also clarify, like if you are doing 2,000, let's say if you're doing a monthly payment of 2,000, do not put a comma between the 2 and the 0. Just write it like 2,000, okay? Don't put a comma because then it's going to confuse Excel in terms of your command. So just keep that in mind. And then my present value is how much I have currently. Now, if you notice, we start off with nothing in the bank, so it's going to be 0. I close parentheses, I hit enter. Notice I get 224,736. And notice that matches with what I have here. Okay, so this is a way to kind of help you double check. Okay, so let's look at one more example. So let's look at like 6B. So it says, assume we start saving $300 a month for 40 years. If our A is 4.8%, how much shall we earn? I'm going to do 6B here. So let's take a look at this, right? My R is 0.048. My N is 12. My PMT is 300. And my Y is going to be 40. Okay, so I'm going to plug all that in. I'm going to look at this formula. I'm going to plug everything in. So it's going to look like this. Okay, so same thing. I want to work this part here first. So remember what I do is I do 0.048 divided by 12. And then I'll add 1. So this is 1.004. Okay, I can do this bottom part separately, and I can do this exponent part separately. So 12 times 40 is 480, and then 0.048 divided by 12 is 0.004. Okay, so remember, next step, what you're going to do is you're going to take the 1.004, raise it to the 480. Okay. So I'll have 300 times 6.7948855585 minus 1. Okay, I'm going to divide that by 0.004. Now multiply by 300. So I get approximately this $434,616.42. So we can check using Excel, okay? So let's do this one more time here. So I said my answer is $444,616.42. Okay, so let's enter this in here. So we do equals future value. Okay, so first one is my rate, which is R divided by N. So I have 0.048 divided by 12. MPER is 12 times the number of years. I believe we said it was 40. Yes, it was 40. My present value is 0. Or sorry, my payment is 300. And my present value is 0. Okay. So remember, let's just talk about the order. It is future value, which is my rate, MPER, monthly payment, and 0. Okay, sorry, PMT equals monthly payment. Now notice when I enter that in, I get $434,616.42, which is good. So it does work with what I said. Okay. Okay. Okay, I want to show you one last problem. This is a tricky one, so let's take a look at number 7. It says a 20-ounce drink in Bryson Hall cost $1.35. If we invested this $1.35 into account every day that earns 6% APR, how long would it take for it to be a millionaire? Assume 365 days per year. Okay, so let's talk about this here. When we do a 20-ounce drink in Bryson Hall, costs $1.35. Okay, and so let's see, my PMT is $1.35. My R is 0.06. Now notice I don't know time, and I know my A is going to be 1 million, because we're trying to figure out how long it'll take us to get $1 million. Okay, and assume that N is 365. So this one's a little tricky, because notice this time here we are trying to find Y. Okay, so let's talk about how we would do this here. Okay, so I'm going to plug everything in, so it's going to look like this. So I have $1 million in for A. EMT is 1.35. So it looks kind of weird. Okay, so let's explain what we're going to do. Okay, so I'm going to try to solve for y. Okay, so what I want to do here is I want to get rid of this $1.35 first. So this is what I'm going to do. So I'm going to divide both sides by $1.35. All right, so what happens is this kind of goes away. Put this in my calculator. Okay, you should follow along. You should get 740,740.7407. And so I have here 1 plus. Okay, I'm going to do the 0.06 divided by 12 just to make things easier. So this is 0.005. Sorry, let me show you what I'm doing here. Okay. So it looks like this. Everyone see that? Okay. Now, think about this. I want to get rid of this here. So what I'm going to do next is I'm going to multiply both sides by 0.005. Okay. Now what are we going to do? We want to add 1 to both sides. Okay. So we're at this part here, and some of you guys are like, how the heck am I supposed to solve for y, right? Because notice my y is on top, okay? So I'm going to show you this kind of a strange thing, okay? Hopefully you guys should kind of remember this. The idea is, remember, we do something called the log of both sides, right? So if I take the log of both sides, it looks like this. So the idea is if I take the log of both sides, it looks like this. Okay? And why I'm doing that, remember, is if I take the log of both sides, what happens is my exponent comes down. It just moves down like this. Okay, now in order to be equal, I need to take the log of the other side. So it looks like this. Now, don't get thrown off by this. Log of this random number is actually still a number. Okay? So I want to get y by itself, right? So one thing I can do is I can divide both sides by 12, right? Because this 12 will get rid of this. And I can also divide both sides by the log of 1.005. This will cancel. So it looks like y, you see that this y is me by itself. I can divide, okay? So let me just on your calculator, how would I do this? Okay, just be a little bit careful for this right here. So I'll do log, this is my log button, 3704.703704. Oops. Sorry, let me do it again. Log of 3704.703704 divided by, make sure you put this part in parentheses, 12 times log of 1.005. You can also do it separately. Okay, so it takes 137 years. Okay. Now, if you don't like that, you can do that separately. So let me show this to you one more time. I can show you other way. So I can do the log of 3704.703704. You can first divide it by 12. And then whatever that answer is, you'll divide that by log of 1.005. So you can do it a little bit slowly, and you will still get the same thing. Okay. So if you have questions, let me know. I know this last one's a little tricky. Just take a look at that. Make sure you practice your logs too. But other than that, I'll see you guys later.